And in the case of electricity, it depends whether it's coming from wind or nuclear or gas or coal or biomass power station as to how much CO2 is being released. And then, of course, we, in our own houses, we're losing a lot of heat. And so the more heat we're losing, the more CO2 is coming off at this end. And if you've got gas, of course, your CO2 is being released from your own house because you're burning the gas. So that's roughly the same as about, well, here, it'll be the 500 grams per kilowatt hour. But then a lot of people in the Marlborough area are not on the gas grid and they're using oil, which is, you can see, it's almost as bad as coal in the amount of CO2 it releases. Okay, so measuring heat flow. How do we measure heat flow that's going out through our walls and windows? It's done using a U value. This is the measure, the number of watts that pass through a square metre of solid per hour for each 1 degree centigrade. I'm just showing it that this is the inside of my house, 20 degrees C, there's the wall, obviously the heat's wanting to go out to equalise the
So I mean, there's another really important point on that is, if the outside temperature is, let's say, 5 degrees centigrade, if you have your inside at 25, you've got a 20 degree difference. If you have it at 15, then you've only got a 10 degrees, so you've halved the amount of heat.
So desperate to get.
Yeah. So if you want to look at the total amount of heat loss from your house in a day, you look at the total area that's exposed. My house is, because it's semi-detached, so that's exposed on 3 sides. I'm hoping they're keeping the other side quite warm. The temperature difference, so if it's 20 degrees and it's freezing outside, there's a temperature difference of 20 degrees. The U value, which we know because we've looked at the list, and times 24 hours, because that was only, the U value was only per hour, so now we want 24 hours. So I've measured my house roughly, and the walls, total area is 129 square metre, and I'm hoping that the U value is about 0.5. The windows, 10 square metres with a U value of 2, it says on them. The roof, it's a sort of average, because bits of it are well insulated, and other bits where I've got the tank is a bit more difficult, but there is insulation all over it. So I put that at 0.2. The floor is more or less insulated, except in the conservatory where it's 1. The total area is 261 square metres. If it's freezing outside, 0 degrees, and the room temperature is 20, so the amount lost from the walls, using that formula, the area times the number of degrees difference, times the U value times 24 hours, comes out at 30,960 watts, or 40 kilowatts a day. And the roof, the windows, it works out at 9.6 kilowatt hours per day, and the roof 5.9, and the floor 29. So the total heat loss at 0 degrees C is going to be 85 kilowatt hours per day. If the temperature outside is 10 degrees C, it's half that. It's only 42.5 kilowatt hours per day. And the cost of that would be massive if I was to try to keep the house at, when it's freezing at 20 degrees, the whole house, it would just be, I wouldn't be able to afford it. Tried using this. It's something that's on loan from the library. I must say, when I went and got it, they were shocked and said nobody had borrowed it since 2011. That was So basically, you put the other end of it around the main wire that's coming out of your fuse box, and then this sort of picks up and tells you how much you're using for each appliance, and you can
then plug your information in online. You can see how you are compared to other people like you. Don't know what that means.
You can get an app for it and do it in real time.
Yeah,
on your phone.
And it's, but it has been really helpful, and it has really focused us on what we're using and how long we're using stuff for. It's made us think about, like, if we're cooking a meal, like, do I want all the hobs on in the oven, all sorts of stuff actually, and it has it has reduced our bill.
I bet like
It's,
us
it
now.
would stopped our bill increasing at this point. It's
Yeah.
that's
I
what
bet
it's
like
done.
us now. I bet you know exactly how much water goes into the kettle. to
Yes.
make
Yeah,
soup.
yes. Yeah, it is, but it does. It kind of focuses
Yeah.
you. It's really
Yeah.
helpful, I think.
Solar water heater, and that provides all my hot water from the end of March, more or less, to the end of September. Sometimes it's really hot, other times it's kind of lukewarm, but generally I get all my hot water from that. In the winter I've got gas central heating, which I only have on for 2 hours a day, even in the middle of winter when there's snow on the ground. And most of my heating comes from my wood burning stove, and that is the primary form of heating. It's a bigger wood burning stove than that, but the house is rather bigger as well. I've got an 8.5 kilowatt wood burning stove. What's that?
5.5.
That's 5.5, yeah, okay. And you saw all the tables for what people's carbon emissions are. Mine is 1.2 tonnes a year. So I have really dragged it down. And yeah, in some rooms in the winter, yeah, you've got to wear a jumper, but that's the way it is. I get all of this wood for free, and I burn about 6 tonnes a year. Now that equates to about a quarter of the size of this room, the whole volume of this room. So that gives you a feel for how much wood I need. And I know a tree surgeon who works in Brighton, and she actually takes most of the wood to landfill. That's what happens to it. And she said to me, how much would you burn a year? I said 6 tonnes, and she paused for a moment, and she said, I take 9 tonnes a week to landfill, and she has to pay for that.
That's ridiculous.
Now the issue is that people will only buy pretty logs. They'll only buy oak logs, whereas and they'll say, oh well, it produces lots of tars and things if you burn some pine and things like that. If you burn it hot enough, it won't produce any tars at all. I burn, because it's the primary form of heating, I have my wood burning stove burning very hot all the time. If you're going to get wood, scavenge wood like I do, and actually probably even if you buy in wood, you need to let it dry, and you have to let it dry for 18 months. So I'm thinking about I'm collecting wood, not for this winter, I'm collecting wood for next winter, and that's being stored at the bottom of the garden, and then in next summer, when I burnt my big wood shed, I will take it all out, chop it all, saw it up, chop it up, and reload the wood shed. And the other thing, if you don't want to use a big saw, just use a bow saw. Bow saws will cut through stuff really, really easily. I mean, an ordinary saw won't do it. There you go. Simple as that. And that's it, done. There's a couple of things about buying your wood burning stove. Is the bigger your wood burning stove, the bigger the logs it will take. Mine will take 18-inch logs, so it saves a huge amount of energy when I'm chopping it up because I can get really big logs. Sam's is somewhat smaller. What's the big?
13-inch.
13 inch. Actually, that's not too bad. Some will go down to 10 inches.
Yes, ours is 10.
And then you get a delivery of logs, and you find that some of your delivery doesn't actually fit in the wood burning stove, which is a pain. There's a friend of mine at work. She keeps coming in with a bag of logs, saying, "Can you cut these up for me? I can't fit them in my wood burning stove." So those are the toys. And then we come to the big toys, which are much more fun. And chainsaws, I have to say, are the most dangerous tool that you'll ever use. They are fearsome things. And when everybody gets together who uses chainsaws, we always tell stories about accidents we've heard about and people dying. And there are loads of chainsaw accidents every year.
I've got a scar on my knee from one.
Have you? Yeah.
And I went on a course. And
Yeah.
I still got it. I hit a knot or something, and it just
And it kicks
came
back.
kicked
Yeah.
back. And,
Yeah,
And-
they are
half an
really, really dangerous things.
Yeah.
But they're such good fun to use. They are just brilliant.
They are.
And
It's
the-
excellent. Okay.
Absolutely.
Now, this is a fence post, and fence posts have nails in them, and you should always check it first. I mean, after a while you can check it really quickly, and if you hit a nail, it's not going to automatically jump back, but what it'll certainly blunt the chainsaw blade, and occasionally it knocks teeth out of them as well, so you have to then buy a new chain. About 16 quid for a new chain, but a good one will last you for quite a while if you keep sharpening it. I mean, normally you're doing logs which are way bigger than that, and you need to split them into 4 or 5. But this one, I was going to try and scavenge, because we've had a storm, there should have been loads of trees down, I was going to try and scavenge some wood on the way up, but there wasn't.
Did we had nothing?
Yeah, I don't want to already take them.
So, there you go, like that. As easy as that.
Dry, I suppose.
Yeah, that's right.
Can you do the moisture test again, the difference between these two?
So, does anyone want a part J?
Yeah.
Oh, I've always wanted a bar.
So this is one of the logs that Sam's just had delivered. Last week or something?
Yeah.
Yeah.
And it says it's been stored in a shed for a year.
And that's measuring at 38% humidity at the moment.
Wow.
And you really want it around about 20 or less.
Or 15 even.
Yeah, 15
Yeah.
go. Okay, this is a bit of oak that came out of a wood in North Wiltshire last year, I think. And it's been stored in my wood store this year.
It's a proper wood store.
Well, not really. It's an old shed. But actually it has dried out to about 18,
Interesting.
19, so it's a bit closer to what's required.
Goes down. Wood burning stoves should be, these days, are at least 65% efficient, and probably up to, well, some of them claim to be 80% efficient. I have to say, I find it difficult to believe that. How can you have an 80% efficient stove? By contrast, an open fire is 15% efficient. So don't have an open fire, they're just no good.
Anymore now. What are you going to do with Santa Claus? He can't go down the chimney anymore now.
He's very thin, he can stand up down the inside.
I'm coming for a cat flap.
Yeah, okay, good.
Right,
Cat
this
flap,
suggests having the door open a little bit. I don't do this actually. So I'll explain to you how wood burns. It's different to coal. The coal itself burns, and you have to supply air to the underside of the coal, and that makes it burn. Wood's different. It doesn't burn the wood, it burns the gases that are emitted from it, and therefore you don't want the air coming up from underneath, you want the air circulating around in the fire chamber at the top. And that means, and that's what this kind of air wash system is. Ooh, look at that, it's going. Hooray.